Okay, so implementation that we came up with pretty early on. I want to talk about why we made Fluxible, what challenges it solved for us, and some of the challenges that we're facing right now as we try to scale it out. So before React, we were in a world with YUI. YUI was invented at Yahoo. It was basically the jQuery before jQuery. It provided the cross-browser abstractions needed to manipulate the DOM, provided a nice module layer. It was really nice. And then we started to move into doing server-side rendering with Node. And that's where we realized YUI can't simply be moved onto the server. But we did realize the importance of sharing code between the server and client, so we used Dust.js templates to achieve server-side rendering. So this is when a new thing called React came about, and we thought we could just swap it in and use it as a new template language. But we soon realized it was more than just a template language, because React comes with built-in events and well-defined lifecycle. And what that means is you can now start to put the code, UI, like your UI logic, right where your UI markup is. And that helps a lot in terms of making your code easier to reason about. Also with React, you no longer had to touch the DOM as much because it did efficient DOM updates with its virtual DOM diffing. So that meant you didn't really need the cross-browser DOM abstractions that YUI or jQuery might provide. And all of this with declarative templates that you can actually write in pure JS without actually transpiling them. It just made React a really awesome win for us. So as we started to realize the benefits of React, Flux was becoming a thing. And if you're not familiar with Flux, Flux is a unidirectional data flow. Actions dispatch some data into your stores, and then your views react to it and render. And you can fire off more actions responding to user events. But we wanted to get this working on the client and server. So how does this look on the server? Well, you don't have UI events, but it is a concurrent environment. That means you have two different users accessing your site at the same time. They get through the dispatcher, they get to the store, and to the view, and this is where it gets complicated because the view doesn't know what to display. Because now the store is a singleton, and so the latest value always overrides the previous value. So that doesn't work on the server. We realized what everybody else who was working on Flux at the time realized, which is we have to class the dispatcher and stores and instantiate them per request. And that solves our simple problem of each user getting their own view and own data. So this is all well and good. You have Flux on the server and client. So how do we make this truly universal? How do we make the server, how do we make the client pick up where the server leaves off? Well, when you're done rendering on the server, you send your markup down. But that's not enough for React. If you call react.render, it'll throw away the markup and render its own markup because React needs the state that you use to generate the markup. So you also have to send down that state. Once you do that, the browser, the client-side Flux can take over. And you have that. So whereas before, we thought we were only going to share React on the server and client, we were now sharing Flux and Fluxible specifically. This allows us to get rid of YUI on the client and instead rely on polyfills. So what this means is we write all of our code in just pure JavaScript whenever we need to, and we rely on polyfills instead of the cross-browser abstractions you might get with the jQuery or YUI. We were also able to get rid of our MVC abstractions and share Flux in both the client and server. And we were also able to use Babel to transpile our JSX because we soon learned that JSX was a lot more fun to write in. I want to quickly address CSS as well. So Atomic CSS is something that Yahoo's open sourced, and I don't want to go too deep into it because it's a talk on its own, but it's a really new approach to CSS you guys should check out. So what we have is a really cool Flux implementation that we use internally. Our internal framework wraps this Fluxible with our own Fluxible plugins Fluxible was designed from the ground up to be pluggable so that you can use it for whatever use cases. We have our own Express middleware, and that's kind of it. That creates the stack for the entire Yahoo media organization. So one quick caveat is that before we made Fluxible, this framework was a thing at Yahoo. So we actually realized all the parts of it that we could open source, that were generic enough to be open source. We abstracted it and then open sourced it. So now that we've kind of briefly touched on React and Flux that you guys are probably already familiar with, what is scale? What does it mean to be developing applications at scale? Well, for me, it means two things. There is scale of development and scale of product. Scale of development is that. That is basically our Webpack dependency graph. So you see like hundreds of modules, and that whole tree doesn't even fit inside of this slide. It's huge. And this is only one app. We have a lot of applications at Yahoo, and we have dozens of teams and hundreds of developers working on this. So how do we sanely keep developing? Well, once you get to a certain size, you have to invest in the right tools so that your developers can work productively. So some tools we use are ESLint and JSCS. This helps you enforce code quality across all of your repos. We use Grunt to run our tasks. We share Grunt tasks between projects. We use Yeoman so that people don't have to start off with a completely blank slate. You get a good starting point for your apps and new features. We use Webpack's dev server and hot reloading features for really cool like live reloading awesomeness. And we use our Jenkins CI/CD for testing and developing features without worrying about whether you've broken something else. And really, I know I'm just throwing a lot of tools at you, but it's not important what tools you use as long as your whole team is using the same tools. It's not important grunt versus gulp, but you pick one and you stick to it. That really allows the maximum shareability. So next, the scale of product. It's easy to think that Yahoo is just one product, but it really is a lot of products. If you quickly look at our menu, you realize there's a lot of diverse products here. How do we go about creating an internal framework that is able to support all of these use cases? We have to let each one of these teams, and there is a team behind each one of these products. Each one of them needs to work independently, but also we need to allow them to reuse as much as possible between the products. Let's look at one of them, the homepage itself. If we were able to start from scratch and design yahoo.com over today, if I gave this to a web developer, he'd be able to slice it into a 3-column layout, identify the important parts of the page, and come up with the layouts. Come up with the components that fit in the layout. This sounds easy, but at a scale like Yahoo, what happens is every single one of these components is designed by a different team. That actually makes it really complicated when you want to put it all together into one cohesive experience. And this problem is only complicated more by something we call context. Context is basically how the user is accessing the site. And this is very important. It's extremely important as your app starts to scale. A few examples of context. Device. A user could be on a smartphone, on a desktop, on a tablet. It's important not to serve the same exact experience to each of those devices. A small application or a startup might serve the same exact application across all 3 devices. And you might hide the fact with some responsive CSS. But what's really needed is responsive JavaScript. If half the code in your component is never seen by your desktop app and is only meant for your smartphone app, and vice versa, is there really a point in serving the extra bloat to either device? I think we can do better. So authentication. In the same line of thought, if you have a logged in and logged out user, do you want to penalize the logged out user with all of the extra logic that comes with the logged in user? Maybe your logged in user is like a completely single page app with like so many like routes and features, but all the logged out user needs is just a way to sign up probably, and the value proposition. So let's think about browsers for a second. It's easy to ignore, understandably, easy to ignore IE these days. But when you are dealing with a scale like Yahoo, we have 1 billion monthly active users. Even if a tiny fraction of them use IE6, it becomes not affordable for us to lose those users and give them a broken experience. Even if these low-grade browsers don't support the fancy web page, fancy React applications, you can still give them a server-rendered page, have it look nice on the first load. You don't have to just serve them all of your JavaScript assets and have them not even load. So context has a lot of dimensions to it. Devices, authentication, status, browsers. You could even include A/B testing and locales. It could go on. And it only increases the complexity of your app. A first pass at this might look like this. You could just be like, oh, if I'm on the smartphone, let's render this guy. And if I'm on the desktop, or if I'm on this A/B test, if I'm in the experimental group, if I'm in the control group, you could do this all over your application. And this might make sense to you. But if a lot of developers are doing this in different parts of the code base simultaneously, you have this bloat everywhere. And people are afraid to delete these giant if-else blocks. So we actually don't want to do this. What we really need is a way to serve the minimal resources needed for the best possible user experience for that one request. And our solution for this is something we call dynamic page composition. It's essentially logic that will decide how your page will look and what resources your page will need based on the current context. And there are 4 important resources when it comes to pages: layouts, components, data, and assets. I want to go into detail about each of these. Layouts. Layouts are easy. They basically take in components as input, and then they arrange them into different arrangements based on what context you're in. The top one could be a desktop, and the middle one could be a tablet view or something. So to put simply, they take individual parts of the page and organize them into a page. React is extremely well suited for this because you can actually pass in components as props, and then the React component can just return markup. This is great, especially in React 14. Your layout functions can be pure functions. They just map components to markup. Context is extremely important here. So now let's consider components. It's important not to reinvent the wheel every time you write a component, especially at a large scale, because as your team starts to grow, you can envision that some teammates might be working on a feature, and that exact logic might be needed somewhere down the line, but people don't know that somebody's already written this. So it becomes important to maintain some sort of internal knowledge base where people can go to figure out if this kind of thing has already been written. So for example, if I wrote an image component, and this image component contains some commonly used logic where it won't load the image right away, it'll load the image when it scrolls into the viewport, saving some bandwidth. That sounds like a useful piece of code. I wanted to use it in an article page for the inline images. Well, this is great, but what if somebody else wants to write a gallery? This sounds like a great idea for a gallery as well. The same logic could be applied here. But we don't want them to rewrite it, because then now you have 2 image components that you're loading. So what we do is we have good guidelines on how to create reusable, composable components. React kind of already, just by its nature, enforces composability. But if you take care in the API that you expose to other users and how to use your components, you can really make them truly reusable across any number of contexts. Data fetching in Fluxible is actually quite simple. Actions are the only parts of your application that's allowed to be asynchronous and fetch data. They have access to this library called Fetcher. And Fetcher has access to all of your REST APIs. Once your REST API returns, Fetcher transparently returns the data down to your action. And the cool thing about Fetcher is that it works isomorphically on the server and client, and so you can write the same exact code and have the same exact data returned to you on the server and client. So once you get the data back, you can, sorry. Once you get the data back, you can follow through with your Flux flow, and the rest of your actions can also talk to Fetcher. This is well and good, but what about the first time you render an application? How do you get the data that you need for the first render? Well, if you look at the view gets its data from the store, but the store gets its data from the action. So somehow the action needs to know what view it is going to render. This looks like it's easily solvable, because when you're on the home page needs a certain amount of data. When you're on the next page, whatever page that you've defined, it needs to render a certain component. And it's easy enough to assume that that component has a certain data that you know about. But when you're dealing with an application that is huge and that has a lot of nested components, it's hard to reason about what data could be needed when you're trying to run this application. So it becomes a problem to determine the data that you need at runtime. So actually, one solution to this is Relay. Relay kind of solves this in the same exact way that we do. But Relay solves this by attaching statically onto every component some GraphQL query. That gets extremely complicated, and I don't want to talk about it. But all we do is we declare an action statically on the view. And we've already talked about the actions being able to access the fetcher and fetch whatever, any kind of data they need. It's just a pure function. So when you declare statically an action on every view, you're able to access these views, access these actions without actually rendering. You can run these actions before you ever have the need to render. Populate your stores, so when it comes time to rendering, you can have all your data ready. We can see an example here. If a user is trying to navigate to an article page will map to an article view. And the article view will have its own initial action. So the navigate action will go to the article action, and then we'll fetch the data that we need. It'll come back to the navigate action, and the navigate action will continue through the Flux flow and render out the component. So next, let's go back 1 second. So here you can see that the view and the action are actually tightly coupled right there. It's also easy to imagine how this, in addition to the view and the action, the data service and the store could also be coupled to the article view. So we came up with a concept called bundles, which are the actual individual modules that are shared between teams. A bundle could be a component, but it could also be a store, an action creator, service, or CSS that this component needs to render. So we allow users to package these up as they would and publish them to an internal NPM registry. And this really allows maximum reusability, because now you have other users, they can just install it, require it, and see if that component solves their problem. If not, they can just get rid of it. But yeah, facilitate maximum reuse. Bundles. So once you have these bundles, it's time for sending them down to the server. So in the old world, in an old single-page application, you have all of your bundles or assets. User comes to your page, he wants the bundles, he gets all of bundles. But we can do better than that. With smart asset loading, if a user comes to your home page, you show them just the home page. If a user then exhibits some action, like a scroll, you can then load, say that's the comments bundle. You can render the comments at the bottom of the page. And then if the user tries to navigate away to a different page, you can load the assets that you need later rather than now. So if we go back to the question of serving the minimal set of resources for the best user experience, have we achieved that? Well, with flexible layouts, reusable components, statically declared data, and smart bundle loading, we have all of the resources we need. But I don't know if we achieved the best user experience, but we have definitely achieved a better user experience. This will lead to faster page loads, smaller K-weight, and fewer requests made by the app. So what's next? Well, we're not quite done yet. These next few topics that I'm going to talk about are the challenges that we're facing right now, and these solutions aren't fully vetted, and if you guys have seen these problems before, please come talk to me. Time to first byteflush. If you guys aren't familiar, this is how long it takes from the time you get the request to the time you respond with something to the user. So typically, with a React app, this is probably what you do. You get the request, you route it to the proper assets, you get the data that you need, you render your components, and you send it down. But actually, you don't have to wait this long. You can flush as early as needed. You can flush all of your assets down so that the browser starts to parse all the JavaScript files as early as possible while you're still rendering your React components. This definitely provides a performance boost. What's even better than this is actually to flush more often. But this is harder to do because with our current architecture and with most architectures I've seen, there is one single giant React component at the top, and React rendered string is a synchronous method. What that means is you have to actually wait until this whole thing completes before you can flush down anything. But what is ideal is to flush down markup as it becomes ready. So one thing we're considering doing is to have multiple trees that we can render. So the next is a concept called progressive rendering. And with progressive rendering, we're able to decide dynamically whether we want to render and serve data on the client or the server. So if you're familiar with the concept of above fold and below fold, everything in your viewport when you go to a website is above fold. And those things we definitely want to fetch the data and render server side. But again, going back to a comments module at the bottom of the page, you don't need to render it client side. You don't need to render it server side, so you can send it to the client and defer rendering it and save that XHR. So some few problems that we're facing right now, bad parts of React and Flux. Check some issues. Any small error will throw away all your markup, and that's kind of just bad. So our solution that we're trying out right now is to have multiple React render trees so that if one part of the markup in one render tree fails, the rest of your markup gets reused. Other is iframes. If you ever try to re-render an iframe, it actually just reloads the whole thing because you can't diff the DOM inside of an iframe. So that's another issue that we're facing right now. It's not easy to solve with React's virtual DOM, unfortunately. But if you have any ideas about these kind of problems, come talk to me. I have some Fluxible shirts to give out, so feel free to come grab them.
Awesome. Great. Cool. We have still a couple of minutes, so we can go through the questions.
OK. So why Fluxible over Redux? Wow. So we just actually released this thing called the Reducer Store add-on, which lets you use Fluxible as a giant reducer store and add reducers to it. So they're not necessarily mutually exclusive, but it's Redux leaves a lot up for interpretation outside of the reducers, because how you, like I was talking about, the layout, all that logic can be extremely complicated to handle outside of Redux. But we're experimenting with it. The Reducer Store add-on is something we want to try to see how the performance plays out. Right now, we have a lot of stores that, that a lot of different teams made, and so it's hard to ask them all to be like, hey guys, this new framework came out, can we all switch? So I hope I answered that one. Private NPM. What's been our experience using private NPM? It's not NPM Enterprise. We actually run our own NPM. It's called YNPM. We try to put a Y in front of everything internally. But we have a guy, he maintains YNPM. It works the same. We just have a YNPM command line, and so I think it's a wrapper around the actual NPM. But it's been extremely useful for us because when you're able to not have to go to another repo to like clone it or anything to share code, you can just install it. That helps, especially in release pipelines, because you're able to install the latest versions instead of copying other people's code internally. Do I consider using React Server Renderer for initial page load? Yes. Yeah, that's one of the reasons we do it, is because the initial page load will be much faster if rendered on the server instead of letting the client do all of that logic, especially because of the data. Because on the server, we're able to do all of the data fetching. So if our page has like 5 different modules developed by 5 different teams, that's 5 different backends that we need to talk to. We can do all of that very fast on the server because they're co-located in our databases. But on the client, if you had to do XHRs to all 5 of them, it's very slow. How are stores initiated when calling statically linked action of a view? This is interesting. We actually are able to statically, when I mentioned bundles, when you npm install a bundle, it comes with stores. And those stores are all like, we statically crawl our app, and we know how many stores there are. So when an action needs to dispatch some data, so these statically linked actions, once it gets the data, they dispatch it to the dispatcher. And the dispatcher, based on what the actual action string is dispatching, it's able to recognize what stores need to be instantiated. Because we've already parsed all of the stores and know what all the handlers that the stores are listening for, what are all the actions that they need. So we only instantiate the stores that are needed. We don't instantiate all of the stores. Can you have cycles in a tree representing actions? I'm not sure what that means.
No worries. I think we're out of the questions with the proper amounts of likes. So Rajiv, thank you so much for your time and for presenting this.